Alrighty people, welcome along to the channel and some linear graphing work. Okay, been through a bit of this so far, and today we are looking at how to find the equation of a line. Alright, and have a look over here on the screen, which is not over here to you because you've only got one screen in front of you. So we're looking at it in the form of the standard equation being y equals mx plus c. Now, from previous lessons, you might remember that as having particular properties, and they are that the m is gradient and the c represents the y-intercept. So every single time that's going to come up, all we need to write this equation is the value of the gradient and the value of the y-intercept. We start with these lines over here. Color. Let's do it grey. Okay, so for A, our values of the y-intercept and gradient. So the gradient's 2 and the y-intercept is 5. So we substitute those two in directly in for those numbers. So m becomes 2, so 2x plus 5. That's A. Second one, we've got the m value, which is our gradient of 4x, and -1. Okay, now if, for instance, you did that slightly different, you may have done something like this. Okay, so 4x plus, we've not got a plus there, okay, might have got 4x plus -1 for you to see value. Now, a plus and a minus next to each other equal to a minus. So you're still going to come out with 4x minus 1. Alrighty. And last of all, C, y equals -2x plus 5. Okay, so it's got a negative gradient there. Hopefully we can pick up that pretty quickly. Right. Next one. Next one, we have to find the values of m and c. So let's do the blue line first. Okay, so blue line, and we've got, let's find our y-intercept first. So c is equal to, and you can see there, it goes to our origin. All right, so c equals 0. Then our gradient, we have to use the rise and run. So I might look at these 2 points. I'm going to go between here. I'm going to try a different color because that's not coming up. As well, I'm going to go between this point and this point, just because I feel like it doesn't matter which two you pick. So I go from there, I find my rise, which goes up, that's +2, and then I go across, and that runs across 2. All right, so if I put that into my equation, then I've got 2 over 2. Right, 2 over 2 is equal to 1. So our equation becomes, once we put it into y equals mx plus c, our equation becomes y equals 1x plus 0. Now, a few of you might be able to clean that up. So we know that if we have 1x, that's the same as saying x, and 0 is the same as not having anything there. So that's our final equation, so that's best for. The next one, our red line, is, let's find our C first. So you can see the C. You can identify that the y-intercept is down here at -5. Right, so -5 there. And our gradient, so you can see, let's find 2 places where it crosses the. So we've got that, and I'm going to pick that and that. Cross nicely. So I'm going to find our rise. So for our rise this time, I've got to go down. So that goes down from 5 to 0, so that is -5. And it goes across from -4 to 2, so it goes up by 2. So I've got -5 rise over 2. Now, 2's into 5 is 2. Sorry. 2's into 5 is 2 with 1 left over. Put the 1 on the top as the remainder, don't keep the denominator. Now that's a negative divided by a positive, so that becomes a negative. As you can see, because this one is going down, we should always have that as a negative value for the gradient. So the gradient is negative 1/2 or negative 2.5. Either of them are fine. Pop that into our y equals mx plus c. Y equals m is negative 2.5 x plus c, which we saw earlier was negative 5. And that's your equation for the red line. Down to some of the slightly harder ones. And here we've got find the equation of the line which has a gradient of 2/3 and passes through the point negative 3, 4. So this is using our substitution into an equation to find missing elements. So for this, we know that in y equals mx plus c, we know that the m is value is 2/3. So I can substitute that in. We also know that a point on this line, when x is equal to negative 3, y is equal to 4. I can plug that into my equation as well. So when x is negative 3, y is equal to 4. And we don't know c. Now, for those of you cool with this, you'll notice that if we have 3 out of 4 parts, if we're only missing one part of an equation, then we have the ability to find that last part. So I'm going to multiply 2/3 by negative 3. So 2/3 times negative 3, which is the same as 3 over 1. So we get negative 6 over 3 equals negative 2. So 4 equals negative 2 plus c. Now we need c on its own, so we need to transpose with c. So c, so we add 2 to both sides to get rid of this 2 there. So they cancel each other out, and 6 is equal to c. So now we've got our c value, and we were given our gradient value there. So we can just plug both of those into y equals mx plus c and find that our value becomes y equals 2/3 x plus 6. Alrighty. Next one's the same. Now there's less information, well, different information, not less, there's plenty of information. We're shown 2 points on the line, and that's it. Now hopefully, if I gave you 30 seconds, or if you pause the video, ask yourself, what can you find from those 2 points? Now that you've started playing the video again, hopefully you're going to say, I can find the gradient from 2 points. If I know the gradient, we can also use what we did up here to find the rest of the information needed for the equation. So I can use one of those points to substitute in, doesn't matter which one, and I can find c. So let's go and find the gradient first. So I've got, it should be weird, but let's just make sure we see that negative there. So I've got, let's do 3 take negative 2 divided by 3 take negative 1. Okay, so I've used this as x2, y2, and this was x1, y1. Alrighty. So we get 3 take negative 2 is 3 plus 2, which is 5 over 4. Okay. And that equals 1 1/4, or 1.25. Now we've got that, we can go and substitute some stuff in. Now I'm going to use this point for no other reason than it gets rid of some negatives in it. I'm going to substitute 3 and 3 in for y and x into y equals mx plus c. And this is all to find the value of c now, because I've found the gradient here. We have that at the start of both of them. So with that in mind, y equals 3, m is 1.25, and x equals 3, and we don't know c. So 1.25 times 3 is 3.75. Yeah. C. Now we need to subtract. I like doing it in different colours. It just takes half a second to change. Subtract negative. So we're going to subtract 3.75, and we're going to subtract it from this side as well to balance both sides of the equation. So that's to get rid of that, so that C's on its own. And then 3.75 is negative 0.75 equals C. Right, so now we've got C, that bit there, that bit there, and we've got y equals 1.25. Sorry, might be able to hear my kids in the background. 1.25 x as the gradient, take 0.75 is our C value. All right, so the little keys there is 1, find the gradient. Find the gradient. 2, substitute. Ooh, that's a bad B. Substitute the gradient and a point. And when you've done that, find C, and then lastly substitute into your y equals mx plus c, your m and c values. Okay, hopefully that's been a help, gang. Leave a thumbs up, etc. Comment if there's anything in there that didn't quite make sense, and rerun through it if you don't understand as well. Okay, hopefully it's been all right, people, and I will talk to you next time.